Good morning all of you. Today we are going to discuss about permutation sequence. This is a lead code 60th problem. Then coming to the problem statement, the set 1, 2, 3 and so on n contains a total of n factorial unique permutations. By listing and labeling all the permutation in order, we get the following sequence for n equal to 3, that is 1 2 3 1 3 2 and so on 3 2 1. Our problem is given n and k, the written kth permutation sequence. Then we will see what is a kth permutation sequence. In our example, take example, if assume it is n is equal to 3, that means that first 3 numbers we have to generate all the permutation 1 2 3. Then with 1 2 3, how many different permutations are possible? If you see 1 2 3 in ascending order 1 2 3 1 permutation, 1 3 2 1 permutation, and 2 1 3 2 3 1 3 1 2 3 2 1. That means that 6 permutations are possible with n equal to 3. Suppose if n is equal to 2, values 1 2, how many permutations are possible? 2 1. 2 permutations are possible. Suppose if n equal to 1, only one permutation is possible. That means that if n is equal to some value, m value, the number of permutations are n factorial. N is a number, then number of permutations are n factorial. So n factorial permutation, we have to find kth permutation. Here in your input, number of values and kth permutation you need to find. Suppose numbers n numbers are there, n factorial permutations are there, so you need to find kth permutation. For instance, permutations normally start from 0 1 2 3 4 5. 6 permutation, kth permutation, for example, if it is a 6 permutation, that normally will store as 5. Suppose if it is a 5th permutation, we will take it as 4. That means that k and k minus 1th permutation we have to take. Now for a instance, the input assume n is equal to 3, k is equal to 4, kth permutation. This is combination 0 1 2 3 4 5, but first permutation, second permutation, third permutation, fourth permutation, fifth permutation, sixth permutation. 4 means that normally in 0, if you start from 0, this is the permutation 2 3 1. Suppose if they ask represent in the string, we have to represent 2 comma 3 comma 1. This is a way you have to. So what you need to do, in general, you have to find all the permutation. In the all the permutation, kth position, what is a permutation that you need to display. That is a problem statement. This particular problem statement you can do in 2 ways, naive approach and efficient approach. First I will go to naive approach. In naive approach, we will find all the permutations, and from the all the permutation we will find k minus 1 permutation. Why? Because the indexing will start from 0, so we will take a k minus 1 permutation. Coming to the naive approach, we will generally in Python, C++, Java, the specific libraries are there to find all the permutations. We will use a direct library function. Here Python implementation I am going to write here. Python implementation I am going to write here. Naive approach. Naive method. There is in Python there is a library called iter tools. From iter tools, if you import permutations, all the permutations, whatever the combinations you give, all the possible permutations it will generate. From that k-1 permutation you will display. From iter tools, import permutations. It generate all the permutations. Instead of writing a program, I am using direct library function. Then str of I. Why? Because in this particular problem statement, the ask to display in the string format. For I in range 1 to n plus 1. Why we are taking 1 to n plus 1? Here the values set from 1 to n. If you start from 0, 0 e combination, they are not specified in the program. Because of that, we are starting from 1 to n plus 1. So the values will capture from 1 to n. That's the purpose. Okay. Next, all permutations you have to generate. All permutation, one variable we are taking. And this is in order, right? We will take ascending order, sort all the permutations. That permutations will generate using permutation library function nums. Then we have to generate a resultant string. Output will be a resultant string. Because of that, we are taking for I in all permutation of k-1 permutation, right? We are taking result plus I. We are adding each character in the k-1 permutation. Finally, return result string. For instance, take this example. Assume n value equal to 3, k value assume it as 4. What happens? Then first from iter tool, and this we are importing. Import library function. After importing library function for I in range 1 to n plus 1. So here capture what are the values it will be captured in nums. First value 1 in string format, next value 2 in string format, next 3 in string format. In nums consists of these 3 values after this particular statement. After that, all the permutations we have to generate. After generating all the permutations, we have to sort. So if you sort in ascending order, 1, what are the permutations? 1, 2, 3. Next 1, 3, 2. Next 2, 1, 3. Next 2, 3, 1, next 3, 1, 2, next 3, 2, 1. These are all the permutations possible. All permutations. This all permutations will generate. In all permutation, this is 0 permutation, 1, 2, 3, 4, 5. We want to find kth permutation, that is k minus 1 is the kth permutation, that is 3. So for I in all permutation consists of this, all the permutation, 0 permutation, 1 permutation, this we are selecting. Initially we are taking result as null character, then all permutation k minus 1, this we are taking here. These are the 2, 3, 1, 3 characters are present, first iteration 2 will be added for null string, next 3, 1, so result will be 2, 3, 1, 2, 3, 1 will be returned. So this is the permutation. Now what if you see the computational cost here, this particular loop will execute n times. This particular loop here nums, this is a 3 numbers are there, so 3 numbers, how many possible permutations? N factorial, so 3 factorial. Suppose if it is a number of numbers are n factorial computations are possible. N factorial computations are possible. And sorting, for sorting the after that n factorial into log n factorial, this is a computational cost, then this is loop will execute n time. So maximum the naive approach takes n factorial log n factorial. This is a computational cost. Here our problem statement is only for the number. Suppose if you are take a character, then computational cost will increase a huge, so naive approach will not work. Suppose if it is only for numbers, 9 factorial into log n 9 factorial, this is a feasible solution. But if you are going for the characters and alphabets, all the types of special characters, then it is computationally infeasible. Because of that, we have to go for efficient solution. In efficient solution, we'll go for each directly identify the permutation. How we will directly identify the permutation, that we'll see. Efficient solution, we'll go for first dry run. Efficient solution. Suppose n is equal to 3 and k is equal to 4. As you know, 2, 3, 1 is the your string, required string. That how you will get. That is our problem. Then first if you see the all the permutations 1, 2, 3, 1, 3, 2, 1, sorry, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. These are the all the possible permutations. This is 0 permutation, 1, 2, 3, 4, 5. Now directly k fourth permutation means this we have to identify. How we need to identify? Here 0 character, 1, 2. This all the characters we need to find directly. If you find directly all the characters, then automatically we'll get the permutation without generating all the possible permutations. Then how you will generate? For that we need to know how many total permutations are required. That is a factorial of 3. The factorial of 3 is 6. 6 permutations are there. K permutation 4 means that is k minus 1. K is third permutation you need to identify. Our numbers are, all the permutations are generated with 1, 2, 3. Now, first number, which is the first number that we need to identify. First number we need to identify. For identifying a first number, what you will do? For first number, this is here in first two combination 1, next to two combinations 2, next to three combination 2. That means that two combinations first number is a constant that you have to find. For first number, how many combinations or how many permutations, it is a constant that you need to identify. How you can identify that? Number and n minus 1. First, this is assume it as 0 character, first character, second character. Suppose 0th character we have to find n minus 0, 0th character. So by factorial. So 3 by 6, if you 2, that is, that value is 2. 2. The index value you have to identify. Index value k by factor, that is 1 1. That means that second character will be the first in the permutation. Result I will write directly, that is 2 first. Okay, with program I will generate this. Next, k value also we have to, this is the index value, k value also we have to reduce. How we have to reduce? Second, for how many characters it has to be unique, that you have to calculate 2 by k, 2 modulus of k, 2 modulus of k, then that is a remainder is 1, remainder and 1. Before already this 2 we are placed into the result, so 2 we have to replace with next value. This is a new nums. Okay, now k value is 1 factorial, then this value we have to find n minus I, that is 1, 2, 2 by 2, that is 1, and k by fact, that is 1, this is a 3. 3 will be placed here, and reminder k factorial modulus of factorial, that will become 0 next iteration. Last, this value we have to find. Fact, that is 1, 1 by n minus this particular position value, that is 1. Again factorial value is 1. Again we have to calculate index, k by factorial, that is 0. 0 position, what is the value is there? 1. Resultant is 1. This all the characters we found. Then loop is terminated. This is a result. I think it is bit confusing. Once we write the algorithm, if we trace the algorithm, then it will become easy. Coming to the getting the permutation, get, suppose if you take it is void, I will write in C programming, so it is easy to convert into other programming language. Same logic will work for the all the programming languages. Get permutation, for instance input is n characters, int kth permutation, result resultant string or resultant character array will take. Then first we have to calculate factorial. Int fact initially will initialize to 1. So 0 factorial is 1, 1 factorial is 1. So initially fact value will take it as 1. Int nums we have to calculate. What are the numbers? So I will take in an integer format. You can take in whatever the format you want. Int I, first these two values we have to, fact value and nums value we have to generate. Int I equal to 0, I less than n, I plus plus. From 0 to n minus 1, what is a num values? What is a factorial value? Will nums of I, 0th value, that is I plus 1, right? That is 1, 0 place 1, 1 place 2, 2 place 3 and so on. 1 to n numbers will be placed into nums array. Factorial is fact into I plus 1. I value is starting from 0 because of that I plus 1. Here we are calculating a factorial. Once we will come out of the loop, nums value and factorial value will be placed into the loop. Then kth permutations we are giving. This arrays always start with the 0 indexing. So we are making as k minus minus. K minus minus. So we are making as 0 indexing possibility for I int I equal to 0, I less than n len I plus plus. Now we have to generate each and every character in the position. Fact we already calculated. Factorial value. First, how many combinations the factorial is there? N minus I. Int index. In the nums index, which character will be placed? K by fact. Result of I, initially it is null, we'll make it as nums of index. Then it is in a numeric format. This, if you want to convert it into character format, will make into plus 0. So this index 1 plus 0. ASCII value addition will be taken place. 0 is a character, right? ASCII value. 0 ASCII value plus 1. So value become 1. One character. Because of that, this we are adding plus 0. After that, we have to shift numbers after the index. Why it is, we will let you know. J less than n minus I minus 1 j plus plus. Nums simply shift operation. J equal to nums of j plus 1. Which index value we are placed into results, that value we have to replace with next further values. Once it is completed, k value also we have to reduce. K equal to fact. Then for loop is completed. Once this for loop is completed, then we will return what we have to return, result value you have to return. Okay, this is all about the algorithm. We'll trace with an example. For a instance, same previous example, I will take n value, and what are the important parameters that I will, n value, k value is given. After that, factorial. So n characters, n factorial combinations or permutations are possible. So factorial value we have to compute. After that, then we have to compute nums value, what from, if it is n value is 3, 1 2 3 nums value, then index value we have to generate, finally result. These are the important values. First, initially assume the num value n value is given 3, fact k value 4. That means that k minus 1, third combination we need to find, third permutation we have to find. Then factorial, fact value 4 factorial, not 3 factorial, right? 3 factorial, that is a 6. Nums value 1 2 3. Index value initially it is not there. Result initially it is null. Normally there are n is 3, then 3 characters it is possible. Initially it is nothing. Now for instance, here this is a factorial value, nums value you are calculated. Here nothing is changed, k value is reduced to 3 here. Till now this is a simple calculations. From here I values, for every iteration all the values will update. How it will update, how we'll get a result, we will see. Suppose n value is equal to 0. When n value is equal to 0, when I value is equal to 0, n will not change. N is same as it is. Then factorial value, fact equal to fact by n minus I, fact by n minus 1. Suppose if you compute this, fact is 6, n value is 3 and I value is 0. So 6 by 3, that is 2. Then we have to calculate index value. What is a index value? K value is after reduction, that is a 3 by factor, that is index value 1. Next, nums of index, first position index, this is 0 position, 1 position, 2 position. Nums of index, that is a 2 you will be placed into result plus I, that means that by converting into string. So this particular position you will place 2 second character. After that, in this particular loop, from 2 whatever the values are there, that will shift 1 position ahead. Then nums value become 1 3 3. Why? Because already 2 you are placed, so you can eliminate the 2. Because of that we are shifting. Then again k value you need to update here. K modulus of k equal to k modulus factorial. So factorial value is 2, k value is 3, then modulus value is 1. Next iteration, when I value is equal to 1. When I value is equal to 1, next n value no change. The factorial value fact is equal to fact by n minus 1. N value is 3, 3 minus 1 2, 2 by 2, that is 1. Factorial value become 1. K value, index value we have to calculate. K by fact, K value is 1, factorial value is 1, 1 by 1, that is 1, index value again 1. So the first index value whatever it is there, that we will copy into result by converting into string. So 3 will be copied, one position 3 is there, 3 will be copied. Next, again shift, then no shifting is possible here. 1 3 3 3. Then new k value you have to calculate. K equal to k modulus of fact. 1 modulus of 1, that is 0 0. Okay. Now coming to next iteration, when I value is equal to 2, then factorial value we have to first calculate. First we need to calculate factorial value. Fact equal to fact by n minus 1, so that is again 1. If you substitute all the value, 1. Next, index value you have to, fact value again 1. Index value we have to calculate. Index value, k value is 0, 0 by fact 1, 0 by anything, that is 0 0. Then 0th character, what is 0th character? 1 will be added here, 1 will be added here. 2 3, 1 is there, right? 1 will be added here, 1 will be added. So after this no swapping is possible, no swapping is possible as it is. Result also 2 3 1. Again new k value, k is a 0, 0 modulus of anything, that value is 0. N value will not change anything. N value, next I value become 3, then this condition is false, this condition is false, come out of the loop, result value will be placed. These are the 3 characters, 2 3 1. This combination if you join and if you print, this is the your permutations. Without computing all the permutations, then we can do it. Here how many maximum permutations? N. With n iterations you can able to complete. When you are going for the naive approach, n factorial log n factorial, that many combinations are required. Suppose if you are going for efficient approach, at max n computations you can able to complete kth permutation difference. I hope you understood. If you have any doubt, you can comment on the comment section. Thank you one and all.